This is defense domain. In-depth analysis on global security, military strategy, and emerging technologies. This analysis examines the structural challenges facing European naval power. European navies are confronting a fundamental dilemma. They must defend vast maritime areas, but they are doing so with shrinking fleets and increasingly expensive platforms. Over the past decades, naval forces have prioritized high-end ships. These platforms are technologically advanced, but they are few in number. This creates a structural imbalance. In high-intensity conflict, the loss of a single ship becomes a strategic setback. This dynamic encourages risk-averse behavior and limits operational flexibility. At the same time, the economics of naval warfare have shifted. Low-cost drones and loitering munitions are proliferating. They can be deployed in large numbers at relatively low cost. Defending against these threats requires expensive interceptor missiles. This creates an unsustainable cost imbalance. Defenders are forced to spend significantly more than attackers. Over time, this drains resources and weakens overall resilience. Beyond cost, there is a geographic constraint. Naval forces must operate across multiple regions simultaneously, from the Baltic to the Middle East. However, a ship can only be in one place at a time. No level of technological sophistication can overcome this physical limitation. The core requirement is clear. Navies need more hulls, but traditional shipbuilding cannot deliver this at scale. The financial burden is too high. This leads to a critical conclusion. Future naval power depends on mass, specifically low-cost and expendable platforms. These platforms must be affordable enough that their loss is operationally acceptable. They must carry sensors and weapons, and they must absorb risk. This shifts the focus away from traditional warship design. Instead, the concept of a modular vessel emerges, a standardized platform capable of carrying interchangeable mission payloads. Turning to the next challenge, interoperability. Current procurement strategies across Europe are fragmented. Different nations are developing different unmanned systems, each with proprietary software, unique components, and incompatible architectures. This creates a structural inefficiency. Instead of a unified fleet, Europe risks creating a disconnected system, a collection of platforms that cannot effectively operate together. This fragmentation creates operational risk. In a joint mission, systems may not share data. They may not share spare parts. They may not share command protocols. This complicates logistics and reduces effectiveness in real-world scenarios. Consider a multinational naval task force. Different unmanned vessels are deployed, each designed for different missions. If one critical platform fails, others may not be able to compensate, even if they are physically present. This creates gaps in capability at critical moments. To address this, a structural shift is required. The hull and the payload must be separated. The vessel becomes a delivery platform. The payload becomes the core of combat capability. This requires a shared standard, both physical and digital, a system where any sensor or weapon can integrate with any vessel. Turning to the proposed solution, the EUROGUARD project represents this approach. It introduces a standardized, modular vessel design, supported by a multinational European consortium. The concept is based on a simple principle. Standardization enables scale. Physically, the vessel uses container-based modules. These modules can be swapped depending on mission requirements. Digitally, it operates on an open architecture system. This allows different technologies to communicate seamlessly. This approach solves the interoperability problem. It also enables flexibility. A vessel can shift roles quickly, from surveillance to mine hunting, or to strike missions, without structural modification. At the same time, the design supports mass production. The vessel is large enough to operate in challenging sea conditions, but simple enough to be produced at lower cost. This creates a scalable model, one that allows fleets to expand without excessive financial burden. The project is no longer conceptual. It is moving toward operational reality. A prototype vessel is under construction. Sea trials are expected in the near term. If successful, this model could reshape European naval strategy. Production could be distributed across multiple shipyards. Standardized hulls could be built at scale, while advanced payload systems are developed separately. This would create a more efficient industrial model and a more flexible naval force. Looking ahead, the implications are significant. Naval warfare is shifting away from large, singular platforms, toward distributed, modular systems, toward networks of smaller, coordinated vessels, toward mass and adaptability. This reflects a broader transformation in warfare, one driven by cost asymmetry, technological change, and operational complexity. In conclusion, European navies face a structural imbalance. Too few ships, too expensive to risk, and not enough presence across key regions. The solution lies in modular mass, low-cost platforms, standardized systems, and scalable production. The transition will not be simple. It requires coordination across nations, and alignment of industrial and military priorities. However, the alternative is strategic decline. Projects like EUROGUARD offer a viable path forward. They provide a framework for rebuilding naval capacity and adapting to the realities of modern maritime conflict. This was a defense domain analysis. For more detailed assessments, visit defensedomain.com. Stay informed, stay strategic,